and the distance apart. That is why we said that our capacitance is directly proportional to the area and is inversely proportional to the what? To the distance in factors affecting the capacitor. So that is that. Then your E there is what we call E naught. Alright, your Epsilon, which is alright, E naught here, permittivity is what we call E naught. We call it permittivity of free space. Permittivity of free space. So there are three permittivity in this topic. There are three permittivity. We have relative permittivity, alright, then we have permittivity of free space. Alright, so what is the relationship? I'm going to talk about that as we move on between all the permittivities we have. But anytime you have to determine the capacitance of a parallel plate capacitor, alright, you can use that value. The value is given to what? To be C. The value is given to be C is equal to AE, right? AE, C is equal to AE, area, then Epsilon. I said that everything is equal to E naught, so you can E naught over D. So where this capacitance will be C is equal to capacitance of the parallel plate of the parallel plate capacitor. Then E naught is equal to permittivity of free space. Permittivity of free space. Then D is equal to the distance apart between the plates. Okay, so that is that. Okay, from that, let's look at the different capacitance for different substances before we I talk about the other concept. Okay, now what are the capacitance? I'll mention four. All right, four different capacitance for four different substances. All right, capacitance of different shapes. That's what we want to do. Capacitance of different shapes. So if you want to talk about capacitance of different shapes, don't forget that I mentioned three factors that affect capacitance: area, the separation distance, and the dielectric. Dielectric is actually the nature of material that separates, all right, the plate. The nature of material that separates the plate is what we call dielectric. So now I said as capacitance is increasing, your what area is increasing according to this formula, and here one is decreasing and one is not increasing. So let's look at capacitance of different shapes. Capacitance of different shapes. Capacitance of different shapes. So now for the first one, what is the first capacitance? Let's take a look at number one. The first one is the capacitance of a concentric sphere. Capacitance of a concentric sphere. Alright. The capacitance of a concentric sphere is given to be C is equal to 4 pi E naught, alright, AB over B minus A. Anytime you have to determine the capacitance of a concentric sphere, use this formula, alright. 4 pi, your E naught is the permittivity of free space. Your A is the first radius because your cylinder is like this. Alright, so I will give us the exact diagram of what a concentric sphere is like. So you have something of this nature. I'll give us a diagram from this end. So you have this. So you have A here and you have B. This is what we call a concentric sphere. So if you have to determine the capacitance, use 4 pi E naught AB over B minus A. This is the inner radius and this one is the outer radius. Then your E naught is the permittivity of free space, which is 8.85 times 10 raised to power minus 12 farad. Okay, so that is that. That's the first shape. All right. Capacitance of a concentric sphere is given as 4 pi E naught AB over B minus A. Then let us look at the capacitance of an isolated sphere. This one is concentric sphere. Number two, capacitance of an isolated sphere. Isolated sphere. So for isolated sphere, your C is equal to 4 pi E naught A alone. Alright, this is what isolated sphere. Then number three, the third capacitance is the capacitance of an annular cylinder. Alright, 4 pi E naught AB, this 22/7. E naught is the permittivity of free space. I've given the constant already. Then your A is the radius. Alright, your A is equal to R. Okay, then the third one is what I call the capacitance of annular cylinder. the capacitance of annular cylinder. So the capacitance of annular cylinder is given to be C is equal to 2 pi E naught L over ln B minus ln A. Okay, this capacitance of what? Of an annular cylinder. Concentric sphere is 4 pi E naught AB, internal and external radius over external minus A. Then this one is the what? Capacitance of an annular cylinder. Then number 4 is the capacitance of dielectric. Capacitance, you can say, and dielectric. I told us that dielectric is a device, all right, or is the nature of material that separate the two plates. So what is dielectric? And of course, anyway, you see A and B, is talking about internal and external radius, all right? So A is internal, then B is external. So what is the capacitance of dielectric, or capacitance and dielectric? So if you are having the capacitance and dielectric, how do you calculate for that? All right, it's very easy. So use your C dielectric, all right? C dielectric is equal to, you have E A over ER into D, I think minus T plus T plus T. That's the formula. Your T there is the thickness. Okay, that's what you have. So your permittivity, absolute permittivity multiplied by area over relative permittivity, open bracket, distance minus thickness, T is thickness, then plus thickness. Is what we have as what? As the capacitance and dielectric. And your absolute permittivity, all right, is the product of relative permittivity and the permittivity of free space. Absolute permittivity, LPC, is equal to relative permittivity multiplied by permittivity of free space. So you can write a formula to be capacitance and dielectric to be, anywhere you see absolute permittivity, you now have relative permittivity, permittivity naught, then A over relative permittivity, open bracket, distance minus thickness, then plus what? Plus thickness. This will have a final formula for what? Capacitance and what? And dielectric. Okay, so the relationship between your three permittivities is that your relative permittivity is equal to absolute permittivity over permittivity of free space. Take note of that. Relative permittivity is equal to absolute permittivity over permittivity of free space. Okay, relative permittivity is equal to absolute permittivity over permittivity of free space, and permittivity of free space is given as 8.85 times 10 to the minus 12. Okay, so and your absolute permittivity is the product of relative permittivity and the permittivity of free space. Okay, that's what we have basically from that. All right, so if you are to determine any of those things, all right, you can use them and calculate. So it's not too difficult. All right, I hope so. God bless you. All right, thanks for watching. God bless you.